Hello, wonderful calculus students, and welcome back to the Unit 4 lecture series. We're going to be doing the day 6 notes today. So if you have your notes packet, we're on day 6. Now, last class, we started talking about function analysis, and we kind of went back to the idea that the sign of the derivative gives us the behavior of the function, and that the sign of the second derivative gives us the concavity of the function, and we did all of that algebraically. What I wanted to do today was just kind of go back to graphical, and we had done graphical interpretations of f prime, and f double prime back in Unit 2, but I feel like we should probably just spend another day with graphs, and so that's what we're going to do today. So to start us off, we're going to go back and just remember a little bit about our chart. When we're reading graphs, okay, you're always going to ask yourself, who am I looking at and who are they asking me about? And most of the times you're going to be given the graph of the first derivative, and you'll have to read that graph differently than if it were the function. So let's recall what the derivative graph will tell you about the function. So if I assume I'm looking at the derivative graph, anywhere the derivative graph is on the positive side, I know that f of x is increasing. Okay. Anytime the derivative graph is on the negative side, f is decreasing. Anytime that f prime is 0 or dne, then I know f has a critical point. Okay. And again, critical points could mean a max, a min, or a stationary or leveling point. So I'm going to say max, min, stationary point. Okay, I'm going to try to make this line a little thinner, see if that helps. Okay, now the next part, so that's where the derivative graph or the value of the derivative function. Now let's talk about the behavior of the derivative function. If the derivative graph is increasing, that tells us that f is concave up. If f prime is decreasing, I don't have to write f is concave down. And if f prime has a max or a min, meaning it's changing from increasing to decreasing or vice versa, then f has an inflection point. So we're honestly just going to do a couple of examples of this, and that'll be it for the notes today. So let's assume we have the graph of f prime, the derivative of f. And we know the domain of f is a set of all real numbers in between -10 and 10. So I always peep the domain of f because that's going to help me. And that kind of tells me that I have endpoints here and that we're not going to infinity. Okay, so the first question here, and you guys, honestly, what I would like you to do is just kind of try this problem on your own. So pause this, answer these 3 questions, and then unpause me and see if you got the right answer. Because this is stuff that we've done before, this should be review. So I want you to try this on your own. Give me a good pause. Okay, try it, and then I'll go through the answers. Okay, welcome back. It's always so awkward when I say pause and then welcome back. Let's figure out where the graph of f has a horizontal tangent. Now, again, I'm not looking at f, I'm looking at f prime. And I always write it real big so that I know that I'm looking at the graph of the derivative of f, not the graph of f, okay? I want to know when f has a horizontal tangent. Now, I have to do a translation here. F has a horizontal tangent means that f prime is 0. So I'm looking for all the places on this graph where the value of that function is equal to 0. So that's going to be at -7, -1, 4, and 8. And my justification, f prime of x equals 0. Notice my justification is not 17 paragraphs, okay? It's not even 17 words. It's a small phrase. For what values of x in the interval -10 to 10 does f have a relative maximum? Okay, so now I'm thinking to myself, okay, if f has a relative maximum, what does that mean for f prime? Because that's who I'm looking at. Well, f has a relative maximum anytime f prime equals 0. So I'm actually going to write my justification first, because f prime of x equals 0 and goes from, so to make a max, we would have to go from a positive slope to a negative slope. So I'm going to say goes positive to negative. So this justification will be the same every time. Now I just have to figure out where this is happening. Now notice here that they do give us a domain that's open, so they do not want you to include the endpoints. Otherwise, we would have to have a conversation. So where does the slope change from the positive side to the negative side? That's going to be -7. And the other time would be x equals 4. And again, that's because the derivative is 0 and goes from the positive side to the negative side. Okay, last question. What values of x is the graph of f, concave down? Okay, so now I have to remember, concave down means I'm like frowning on the function, but that doesn't mean I'm like frowning on the derivative, so I need to translate it. F is concave down means that the derivative graph is decreasing. So that, again, that's my justification, because f prime decreases. Okay, I apologize for my handwriting too. I'm getting used to this new stylus. Okay, so now I got to figure out on what intervals f prime is decreasing. Well, I'm going to say -10. And you can include -10. You don't have to include -10. It's kind of debatable. To -4. And then again, it's decreasing from about 1.5 to 6. So because f prime is decreasing, f is concave down. Okay, that was your first example. So now we're going to kind of switch gears. So suppose a function f on the domain -1 to infinity. Now notice this domain. Okay, it's an open half-bounded domain, has the following property. So again, I want you to try this on your own. Take about 5 minutes or so, kind of go through this problem on your own. Try to sketch a graph of f of x, and then we will go through how I would do it. So pause me. Okay, welcome back. Again, so awkward. All right, so how do I go about sketching a graph? Well, the first thing I'm going to do is I'm going to graph all the points. So if I look here, I have the point 0, 2. I'm going to graph that point. 2, 2. Graph that point. 3, 3. And 4, 2. Okay, the next thing I'm going to do is look for any asymptotes. Okay, so it does tell me that as x approaches 1, the function's approaching -infinity. Guys, that is a vertical asymptote. Okay, so what does that mean? As x approaches 1, the value of the function. So if this is 1, it says the value of the function is approaching -infinity. So as I approach 1 from either side, I need to be approaching -infinity. So I'm going to kind of draw little arrows going down towards -infinity. Okay. The limit as x approaches infinity equals 4, there's a horizontal asymptote on the right side. So at the edge, 1, 2, 3, 4, it's approaching a height of 4. So maybe I go like, I'm just going to draw an arrow that's kind of at that height or close to that height. I'm going to erase that part. Oh, that's not an erase. That's an erase. Okay. Let's see. So I got that one done. I got that one done. Okay, the limit as x approaches -1 from the right is 4. Okay, so as I go towards -1, I'm going to a height of 4, and I'm going to make it an open circle. And the reason why is because I remembered my domain that -1 wasn't included, so that's going to be like an open circle there. Okay, so I feel like that's all the grounding points. And so now I'm going to look for any 0 slope. So it does tell me that f prime of 3 is 0. So I'm going to draw like a little baby horizontal tangent there, and that'll cross that one out. Okay, so now here's what I'm going to look at. I'm going to look at where my derivative is positive and where my derivative is negative, because where it's positive and negative tells me where f is increasing or decreasing. So from -1 to 1, so I do like a little sign chart down here. From -1 to 1, the derivative is negative. That tells me that f is decreasing from -1 to 1. From 1 to 3, I'm increasing. From 3 to 4, f is decreasing. So that's these 3. Okay, what else do we got? And then f is greater than 4. We have positive slope, so we are increasing. Okay. So I got all my slopes. Now I'm going to look at my concavity. It does tell me that my second derivative is 0 at 0, so I probably have an inflection point. And then it tells me f double prime is negative everywhere x is greater than 1. So this entire interval, we have concave down. Okay, so now let's see what that means. Now, they didn't give me any information about the concavity on this side, but they did give me the fact that f double prime is 0, so I'm going to make an inflection point there. I'm not guaranteed an inflection point, but I kind of want to show that an inflection point could be possible there, so I'm going to connect it there, decreasing the whole time. Now, from 1 to 3, I need to increase and be concave down. From 3 to 4, I'm decreasing concave down. And then from 4 to infinity, I'm increasing but concave down. And so it would look something like that. Notice that I do have an undefined slope at 4. This again is an open circle. It's starting to look less and less like an open circle. And that's just a little graph sketching practice. And so you're going to try some problems, and that's all I got for you today, folks. So have a great day.